So section 6.4, our triangles are similar by, notice similar, not congruent, by the AA postulate. Because we know that if two angles are congruent, that means the third angles are congruent, right? We learned that in chapter 4. So triangles are similar if two angles in one triangle are congruent to two angles in the other. We know that they cannot be, the triangles cannot be proven to be congruent, they can be proven to be similar. So if angle B and angle K are congruent and angle A and angle L are congruent, by default, angle C and angle J have to be congruent too. And because our angles are congruent, we would say that our sides would be similar. So we would say that side AB would be proportional to what side in the big triangle? It would be KL. And that would have the same scale factor as if I were to say side BC over which side? JK. Haha. Okay. JK, which would have the same scale factor as what would be the final one? CA over? Yes, JL. Order isn't as important, right? Because we're just saying that the lengths are proportional. We are not saying anything about congruence. Okay, so show that the two triangles are similar. Well, we know that angle H is congruent to angle I. We need to be using the angle-angle similarity postulate. So we need to find another angle. What other angle is congruent? Mary? Well, why would you say F and E? We do not know that they are parallel. That is correct. Natalie? Right. Angle G is congruent to itself by which property? Reflexive, right? Angle G is congruent to itself, right? And so we're looking at the fact that the two triangles share that top angle. And so then we would say that triangle EGI is similar to triangle, what would I say? FGH. So we do want to make sure that when we write our similarity statements, our letters for that figure are in the correct order so that we can find the sides that are going to pair up and the angles that will pair up to. Sarah? No, that one's not. You can. If you want to add it, sure. All right, show that the triangles are similar again. So again, we're looking for at least two angles that are congruent. Raise your hand. Who can tell me one set of angles? Gabby? Angle K is congruent to angle M because they are considered to be what kind? Alternate interior. Okay, give me another set. Aaron? Okay, for the same reason, angle J is congruent to angle L because they're alternate interior. And if you didn't see that, Emma, what could you have seen? Uh-huh. Good. VA, vertical angle. So we just need to show two to be able to show that the triangles are similar. Mary? We're talking about why they are. Why do we know? All right, a school casts a shadow that is 26 feet long at the same time a student standing nearby who is 71 inches tall casts a shadow that is 48 inches long. How tall is the building to the nearest foot? So you guys can make fun of my little drawing as much as you want. But this is my school with a little flagpole on top. And this is my little dude. Okay? Who's standing nearby. All right. Well, right now, anything that we write will always be in terms of a right angle. So this is kind of interesting because it seems intuitive to me, but when I am thinking of a shadow and I'm saying that my shadow is so long, am I talking about the distance from the top of my figure to where the shadow ends, or am I talking about the length along the ground? The ground. But invariably somebody will tell me it's that hypotenuse that is the shadow. No, that is the sun's ray. Okay? So the shadow, so here's my sun. Doesn't that look like a sun? I think that looks like a sun. All right, so here is the length of the school shadow, and it is 71 inches long. And here is, we're making my triangles, and the little dude is only, casts a shadow that's only 48 inches. So from here to here is 48, but from here to here is 71, what? Inches. And this, no, 26. This is 26 feet. And the little guy is 71 inches. That's actually pretty tall, isn't it? That's over 6 foot. Now, is that... Right, okay, so 12 inches in a foot, 60 plus, just a little bit under, almost 6 foot, yeah. He's what? No, he's not. No. He's not that little. All right, so what am I going to do? We know that these are going to be similar because they both have a right angle, correct? And they're both going to have that common angle at the end. So we know that these are triangles that are similar, therefore we know we can set up our proportion. What would our proportion say? How would I set up a proportion? Hold on. All right, I want to see who all can answer this question. Well, let's look. Let's put this with our units in it. What do you think? Isabel? Well, you have to convert 26. Not necessarily. Let's leave it. Okay? Because I'm not looking how many times bigger this guy is when we would want to have him in the same units. So 26 feet, right, is equal to? So we're doing the height of the building to the length of the shadow. So we're doing height over length. And so what do we put over here? Inches. 48 inches, right? So let's look at our units. If we set it up this way, what do you notice is going to happen in this problem? Will they really? Aren't they going to cancel? Inches over inches will cancel. And so the only unit that we will truly have is what unit? Feet. Okay? Well, doesn't x over x cancel? So anything over itself, units included, can reduce down and get canceled. Okay? All right. So that leaves us then with simply x over 26 feet is equal to 71 over 48, which means 48x is equal to 71 times 26 feet, right? The only unit that we're carrying with us in this problem is feet. Would you agree? And so we would say then that x is equal to what? 71 times 26? 1846 divided by 48 gives me what? So 38.45, let's do 46 feet. Yeah, that's fine. Carry that to maybe a couple of decimal places. Oh, did they say to the nearest foot? Oh, well then what would the nearest foot be? We would need to say 38 feet. Right, thank you. I didn't read my question carefully. Okay. Do you write these or use like... No, I write them. Sometimes I write them. Sometimes I get extra examples. Sometimes I go to worksheets and find them. Megan? You're going to treat it like a variable as long as they're going to cancel out. And in this case, because we did inches over inches, those inches are canceling out. And so we don't have to worry about that. It's going to be just a nice little ratio that we can use. And because they're similar, we know that the ratio of the inches over inches is going to be the same as the ratio over feet. Does that make more sense? Okay. All right. Next one. Determine, this should be if the triangles are similar. If they are, write a similarity statement. So we know that they share, we know that angle O is congruent to angle B because they're both 36 degrees, yes? But over here I have 52 and over here I have 92. So how do I use the AA? Emma? So 180 minus 128, which is the sum of 92 and 36, gives me 52 degrees. That means this is 52. So therefore, we know that angle Q is congruent to angle A. And by the AA, we know that they're similar, right? So by the AA, we have similar triangles. And so what would my similarity statement be? What could I say? Athena? Okay, hold on. Let me get this answered then. What is my similarity statement going to state? What would I write? Elizabeth? Kathleen? Sorry, that was a blast from the past. I called you by your sister. Sorry. Okay, hold on. So when we say the similarity statement, we want to go triangle blank is similar to triangle blank. So try again. Now we don't want to say congruent. We want to say similar to triangle. So if you said A, you want to say Q, O, P, right? Okay. What would our proportionality statement be? If I wanted to go further, and what would we say about our proportionality statement then? And this is what Kathleen, wanted to say. Now I'm second guessing myself. What did I want to say? Sarah? Okay, so you want to, okay, go ahead. Perimeter of A, B, C over the perimeter of Q, O, P is equal to? Okay, and so the scale factor could be OP over BC, which is equal to QO over AB, which is equal to OP. So we got to start with this one again. So that's QP, right, over AC. So we don't really need the perimeter part when we're talking about our proportionality statement, but she went ahead and said that, which is actually correct. We talked about that in another section, right? But the perimeter, when the triangles are similar, the perimeters of each other are going to be the scale factor of those two triangles. Okay. All right. Is that it? That was easy. Isabel. So your quiz tomorrow is 6-1 through 6-3.